Thank you, Mike. So I'll just remind everybody, if you have any questions, to go ahead and use the Q&A feature up in it's probably in the top left or bottom right of your Zoom window, and we can ask the four panelists those questions. So the first one that came in, Mike, this one's for you. Is there an appropriate thickness of active sediment layer that accounts for the nitrogen flux?
So the way that our experiments work, we're running water across the surface of the sediment, and we're interested in the interaction between surface water and the superficial sediments. And it's really just a few millimeters. It's the area where you have a transition in oxygen concentration so that you can have multiple processes, usually nitrification, which converts ammonia to nitrate, and denitrification, which converts nitrate to N2 gas. So it's a relatively thin layer of usually just a few millimeters.
Ask the question that was asked last time of all of you, or of the last set of panelists, and that is, did you learn anything that surprised you when conducting your research? Let's start with Nathan.
I was surprised at how low the nitrogen fixation rates were. I mean, if you look at the nutrient data, it looks like there's an awful lot of phytoplankton out there with almost no available inorganic nitrogen to grow on. And there's all these cyanobacteria there. I was just sure they were fixing significant amounts of nitrogen, but at least in the main channel, it doesn't appear to be the case.
Great. And Astrid, how about the same question?
Based on some of the studies we've done in other lake environments, there was not too much of a surprise that these toxins are present, but in very low concentrations. I think there will be a helpful baseline going forward. I think I'm most excited about is actually to talk more with some of the other study results in regard to flushing of the system, residence times, and some of the nitrogen rates. I think there's a lot of potential to put some of these data sets together. So I'm very excited about that.
Wonderful. Rick.
I had a fundamental curiosity about how the system was behaving to start with. So I started out assuming it was sort of like a river. And I guess there are times when it's like that, but certainly I was surprised at how the entire system responded in a very identifiable way to inputs from the upstream end, as well as a different type of response, but nevertheless a response that extended through the whole system to discharge at the downstream end. And then the oscillations back and forth were interesting, and they were so ubiquitous and pervasive that trying to understand exactly what their implications are in the system, it's not clear, but it was interesting and a bit surprising to see those. We actually have ways to kind of estimate what oscillation time periods might look like in the reservoirs and lakes, and Falls Lake seems to be far away from an oscillation time period frequency that we were anticipating by at least a factor of 2. So we're still scratching our head over that, and that was a surprise. And then certainly some of the 2-layer flows were interesting to observe, and again, something that be nice to try to get a little bit better handle on how how they really contribute in a substantial way to the overall way that the lake works. So
great. And Mike?
So we were surprised that the spatial patterns were not any more clear. The one thing that we did see was really low rates of denitrification in the deepest parts of the lake, which makes a lot of sense because they're probably going to have no oxygen, be anoxic a lot of the time. So that was something that made sense once we figured it out, but there was not the pattern that we might have guessed associated with things like organic matter or where the load was coming in denitrification. And as much faith as I have in the process, it was a little higher than I would have guessed. But it looks really interesting, and having Nathan's work alongside it has been great value.
Great. I have a question here for Nathan. Do you expect the denitrification will be higher in the lake arms? And from a regulatory perspective, does it make sense to manage those differently than the main lake to allow for increased biological activity?
First question, I think it, and Mike, you can chime in here if I'm saying, if you disagree, but I think it's likely that we'll see higher rates in some of these arms, particularly arms that are have a lot of nitrate coming in. Out there in the main lake, there really isn't any nitrate to speak of. So whatever denitrification is going on is coupled nitrification, denitrification. And generally in these creek arms, I think we're going to have high organic rich, or probably more organic rich sediments, as well as nitrate availability. I think denitrification is going to be higher. It's interesting to think that nitrogen fixation may also be higher. Some of these creeks, the inputs are, the N to P ratios of the inputs are a little bit lower than the main rivers. Like Ellerby Creek, for example, looks like has a significantly lower N to P ratio. That could drive up nitrogen fixation. And the nitrate coming in could also, it could be that they balance each other out for all I know. As far as how you manage, if you should manage those differently, I think you could run scenarios through the models to see how you might want to manage, whether or not you would want to manage them differently. But I think getting a good handle on these nitrogen cycling processes in the lake and being able to see differences between the arms versus the main channel. I think you'd have to see how that all plays out before you would decide if you wanted to manage them differently. I think I'll punt on that until we find out. I mean, in a lot of cases, though, we are kind of managing for the tributaries. I mean, that's where the loads are coming in. So
great.
Mike,
did you have any?
Are managing different tributaries differently.
So I think everything Nathan said is right. I do think that a lot of the problems that we see are in the arms. And so it makes sense to get all the information we can in the areas where the problems are manifesting themselves. And he's absolutely right that logic suggests we might see a lot more denitrification there. And that would be important to know in terms of mitigating the sources coming in from the tributary loading. But we could also see more NFIX. So it's the way that nature tends to be, is unpredictable and a little complicated, but it's exciting to have as much constrained information as we do now, and the prospect of a little bit more in areas of concern for the lake feels like a positive.
I do want to mention Dan Obenauer's model for Jordan Lake is it's using kind of this approach of looking at different segments of the lake and the nitrogen cycling within different segments and the N to P ratio as inputs these different segments, and finding that adding the nitrogen cycling processes and taking into account differences in tributary N to P ratios is really important for figuring out management strategies as far as like nutrient reduction strategies. So I think having this tributary arm focus as the next step is it's a good one. I think it makes sense.
Great. So we have one other question for Nathan and Mike. How does the denitrification flux compare with sedimentation? And is there a way to tell whether sediment nitrogen is in an equilibrium status, or if there's some sort of temporal trend there?
That is a great question. And I do not know the answer right now, but I look forward to talking with Brent about it. And I will defer to Nathan if he knows more than I do.
Well, looking at the lake budget, so about 60% of the nitrogen that comes in goes over the dam. So 40% is retained in the lake. And of that, 14%, according to the lake-wide budget, is denitrified. So about a quarter then is retained in the sediments. That's based on, the lake-wide budget. But it sounds pretty reasonable to me.
Great. And there's another question that popped up. Though it's been more, sorry, Peter Robb asked this question. He has recently done a presentation on aquatic climate resilience. And in prep for that, he stumbled upon a picture of the near empty upper Falls Lake from 2008, he thought it was. Though it's been more than a decade, do any of you all think that the extreme low level for a couple of months has had any long-term impact on nutrient cycling in the reservoir, particularly in that upper portion?
Mike?
So, I think it certainly will have a near-term impact as you oxygenate sediments and dry them out and then re-wet them. But I would not suspect that there would be anything enduring from 2008. I would think of that as maybe an annual effect, but that is honestly just kind of an educated guess.
The only thing I can think of is the legacy organic matter from all the roots that would grow. That would be a lot of extra organic matter.
Okay.
That could potentially fuel denitrification later.
Great. Well then, this will be the last question. Mike and Nathan did a pretty good job of having a one-sentence summary right at the end of their talk. And so I'd love to hear, first, I'd love to hear that from all of you, but maybe we'll have Mike and Nathan state theirs, restate theirs as best you can recall to give Rick and Astrid time. But let's start with Nathan.
Okay, mine was just that denitrification appears to be a lot more important than nitrogen fixation. So water quality models can neglect nitrogen fixation.
Okay.
Nathan's definitely right.
Mike?
So I would just add to that denitrification spatially is potentially an important contributor as well. We know that the total magnitude of 45% is quite a bit of the tributary load, but that our results were interesting to look at where it's occurring and its relevance to the challenges in the lake groundwater quality.
Great. Rick?
Well, our study has documented the different responses, and particularly the response to the inputs and how quickly those occur through the lakes, as well as the responses to the discharge. And we believe those are important in terms of understanding nutrient fluxes and contributors to water quality within the lake.
Okay. And Astrid?
I would say that our study so far shows that toxin-producing cyanobacteria are part of the mix, but that it's not indicated that there's highly toxic blooms happening under these conditions, under the lake conditions so far, and that we're excited to have created a baseline and provide some more in-depth targets to keep on monitoring to make sure we keep our thumb on the pulse.
All right. Thank you to each of you, and thank you for all the folks who have submitted questions. I will just remind everybody, if you have questions that didn't get answered or didn't come up or whatever, you can always plug them into the Q&A, and we could either answer them in real time or get back